In this problem, we have a capacitor connected in parallel to a second capacitor. That in turn is connected in series with a third capacitor. We want to know the equivalent capacitance. So let's take a second, draw this out, figure out what on earth is even going on. So our first capacitor, 2 microfarad capacitor, connected in parallel with our second capacitor that's 7 microfarads. Then in series with our third capacitor of 11 microfarads. And we want to know then, if we went from one side to the other, what is the equivalent capacitance for these three, now that we kind of know what it really looks like. And so what I'm going to notice first is, okay, well, if I start here, that gives me 2 different pathways to go from beginning to end, or point A to point B. The 2 and the 7 microfarad capacitors are on separate pathways. They're in they're in parallel like it tells us here. So we want to combine those 2 first. Well, the rule for capacitors in parallel is just add their values together. So if we do 2 plus 7, that's going to give us a capacitance of 9. And as I do that, I want to redraw this circuit to simplify it so I can kind of see now what's going on. So again, the 2 and the 7, we added those together. That has a value of 9. We still want to go from point A to point B, but now there's only one pathway. So now we have 2 capacitors that are in series with one another. And the rule is, if we want to find total capacitance for a series circuit, that we need to say 1 over that equivalent, or that total capacitance, is 1 over each capacitor. So 1 over 9 plus 1 over 11. So if I do 1 over 9 plus 1 over 11, but that's not my final answer. That is equal to 1 over the capacitance. I want to know the capacitance, so I'm going to take the inverse, which is, like turning everything upside down here, or taking and doing 1 divided by our previous answer. And so we get an equivalent capacitance of 4.95 microfarads.